Good day everyone. Here's our question for today. What is the area of the blue shaded region? You can pause this video if you want to give this problem a try. And now let's answer this question together. So, our goal is to find the area of the blue shaded region bounded by this equation x plus y equals 5, x plus 2y equals 6, and the y-axis. Now, there's a lot of way to get the answer to this kind of question. So here's are some strategy that we can use to find the area of this shaded region. The first one is we can use the Fick's theorem. The second one, we can use the Shoelace theorem. The third one, of course, we can use integration. The fourth one is the box method or rectangle method. And the fifth one, we can use geometric approach or just find the height and the base of this triangle, then find the area. Now let's do first the Fick's theorem. So how can we solve this problem using Fick's theorem? So to do that, we need to put this area inside the Cartesian plane, most probably on the first quadrant. So let's do that. And now, the area of this region must be computed using this formula. We have IP plus BP over 2 minus 1, wherein this IP must be the interior points, and this BP must be the boundary points. Now let's count how many interior points are there. On this figure, there's only one. Now how about the boundary points? We have 1, 2, 3, 4, 5, 6, 7, last one is 8. So we have 8 boundary points. Now let's use the formula to find the area of this shaded region. So interior points, we have 1. Boundary points, we have 8. So we have 1 plus 8 over 2 minus 1. Now 8 divided by 2 will give us 4. 1 plus 4 minus 1 is definitely equal to 4. Therefore, the area of this shaded region must be equal to 4 square units. Now, using Fick's theorem, we get the area of this bounded region must be equal to 4 square units. Now, let's have the second one. We have the Shoelace theorem. To use the Shoelace theorem, we need the coordinates of these intersection points. These points, this point, and this point. We can get the coordinates of these points by using the elimination method for this point and getting the y-intercept of these two equations. But the easiest way, of course, is to put this graph into the Cartesian plane, especially on the first quadrant, like this. Alright, now clearly, this point must be 0, 5. This point is 0, 3. And this point is just 4, 1. Now, we can use now the Shoelace theorem. So the Shoelace theorem is equivalent to the area of this region must be equal to 1/2 multiplied by the absolute value of x1, y1, x sub 2, y sub 2, x sub 3, y sub 3, and x sub 1, y sub 1. Now, choosing x sub 1, y sub 1, x sub 2, y sub 2, x sub 3, y sub 3 need to be organized. What I mean by organized, we need to choose x sub 1, x sub 2, x sub 3 in either clockwise rotation or counterclockwise rotation. In this case, I will choose clockwise rotation. So the values of x sub 1, y sub 1 must be 0, 5. The value of x sub 2, y sub 2 is 4, 1. And the value of x sub 3, y sub 3 must be 0, 3. So let's put all those values on our formula. Now what we're going to do is to multiply 0 times 1, 4 times 3, 0 times 5, and then subtract the product of 0 times 3, 0 times 1, and 4 times 5. This will give us 1/2 times the absolute value of 0 plus 12 plus 0 minus the product of 0 times 3, 0, 0 times 1 is 0, 4 times 5 is 20. Now, all of this is 0 except for 12 and 20. So 12 minus 20 will give us negative 8. And now the absolute value of negative 8 is positive 8. Now 1/2 of 8 must be equal to 4. Therefore, again, using Shoelace theorem, we get the same answer. Thus, the area of this shaded region must be equal to 4 square units. And now let's use the third method, which is the integration. Now, using this integration, we need also the coordinates of these points. And we know that we have 0, 5, 0, 3, and 4, 1. Now, also, when we use integration, we also need the formulas for the equations of these two lines. Now, using the first equation, x plus y equals 5, we need to solve for the value of y in terms of x. So let's do that. This will give us y equals to 5 minus x. Now we will do the same thing on the second equation. Solve for the value of y in terms of x. This will give us 6 minus x over 2. We can simplify this further. This will give us 3 minus x over 2. Now, we can rewrite the area of this shaded region in terms of definite integral. We have the definite integral of 5 minus x, which is the upper function or the upper line, minus the lower line, which is 3 minus x over 2, dx evaluated from 0 to 4, because we have 0 up to this point, which is 4. Now, let's simplify. 5 minus x minus 3 minus x over 2, this will give us 5 minus x minus 3 plus x over 2. Now 5 minus 3 will give us 2. Negative x plus x over 2 will give us negative x over 2. So we can now integrate this. So the integral of 2 dx must be 2x, and the integral of x over 2 dx must be x squared over 4. So this will give us the area of this shaded region must be equal to 2x minus x squared over 4 evaluated from 0 to 4. Now let's evaluate this integral. This will give us 2 times 4 minus 4 squared over 4 minus 2 times 0 minus 0 squared over 4. Now 2 times 0 minus 0 squared over 4, this is just 0. So this will give us the area of this region must be 2 times 4 minus 4 squared over 4. Now 2 times 4 is 8. 4 squared is 16. 16 divided by 4 is 4. So 8 minus 4 definitely will give us 4. Therefore, again, we get the same result, which is 4 square units. Now, let's have the fourth method, which is the box method. Now, using box method, what we're going to do is to put this region, this triangle, into a box or a rectangle like this. And now let's have the side lengths of this box or this rectangle. From here, from 0 to 4, we know this is 4 units. And also from 1 to 5, this is also 4, and this top right here is also 4. And now from this point to this point, we have 0, 3 and 0, 5. This is 2. And of course, the other one is also 2 because it's add up to 4. Now, let's use the area of a triangle because what we're going to do here is to get the area of the whole square or box minus the area of these small triangles. So to find the area of the triangle, we need to have 1/2 times base times height. Now the area of this white triangle right here must be equal to 1/2 times 4 times 4 will give us 8 square units. And on this bottom right triangle, this will give us 1/2 times 2 times 4 or simply 4 square units. Therefore, the area of this blue shaded region must be equal to the area of the whole square, which is 16, minus 8 minus 4. So 16 minus 8 is 8 minus 4 will give us 4. Again, using box method, we get the same result of 4 square units. Now let's do the PIP method, which is the geometric approach. In this approach, we will use the formula to find the area of this triangle, of course, 1/2 times base times height. Now, using this figure, we can easily see that the base of this triangle must be 2 and the height of this triangle must be equal to 4. So, we can replace this base of equals to 2 and this height must be equal to 4. And now the area of this triangle must be equal to 1/2 times 2 times 4, or simply equal to, of course, 4 square units. Therefore, the answer to our question must be equal to 4 square units. And as always, we are done.